Let's go over the difference between absolute value equations and inequalities in one dimension. So you'll notice that all of these just have one variable, and the answers then are graphed on a number line. In a different video, we can go over the difference of absolute value two-dimension equations and inequalities. Okay, so what I've done is I've written out a list of absolute value equations. You can see they all have equal signs, and a list of absolute value inequalities, and you can see they all have inequalities. And now for the inequalities, sometimes it's a greater than or equal to, less than or equal to. And there's a couple different rules for the greater thans or the less thans, and we'll go over that. But really, for the less than or equal to or less thans, and then the same thing for the greater than or equal to's, really the steps aren't that different. And whether the boundary is included will be determined by whether it has the or equal to part of it. So if it has the or equal to, it'll be a solid boundary or inclusive, and if it doesn't, then it'll be a not included boundary, and we'll use parentheses and open dots when we graph on the number line. So I'm not going to go over that again during this video, but just note that, and then if you have to come back and refer to why that is, you can listen to that part of it again. Okay, so let's do the equations first. And the equations can either have one solution, and that will happen in number one, or two solutions, or no solution. So we'll see each of those problems now, and yeah, we'll see each of those problems now. Okay, so we'll start with -2 absolute value u equals 0. And on all of these problems, whether they're equations or inequalities, the first step is to isolate the absolute value. And so what that means is you want to add or subtract, multiply or divide by anything you need to do to get the absolute value by itself on one side. So in this problem, we start with -2 absolute value u equals 0, and we divide both sides by -2, and you have absolute value of u is equal to 0. So in this case, when you have an absolute value equal to 0, there is only going to be one solution, and in this case, the only value that we can put in right here for u would be 0 to make it come out to 0. So we have u equals 0. Now, that is the finish of this problem. And let me just do one more real quick so you can kind of see, it doesn't have to equal 0, but if I had -2, I'm just going to make this slightly more complicated, plus 1 in the absolute values equals 0. I would start by doing division by -2. Now the absolute value is isolated, and I still have 0, but this time when I drop the absolute values, I get u is equal to -1. So you can see here two similar problems with one solution. Okay, now let's move on to the next problem with two solutions. So we've got the absolute value of 6w plus 3, oops, that was bad, equals 15. Now, the first step is done for us because the absolute value is isolated. So now what we're going to do is we're going to create two separate equations from this, and that'll give us two separate answers. Now in this one, on the right hand side, you'll see a -15. Now we're going to just solve each of these separately, and we're going to get two answers. So 6w equals 12, divide by 6, and w is equal to 2. Now that's the first one. Let's do the second one. Subtract the 3. 6w is equal to -18, divide the 6, and we have w is equal to a negative divided by negative is a positive, 18 divided by 6 is 3. So see, I have two solutions this time. Okay, let's do another problem. I've got two solutions. So this is the 3w in absolute values plus 3 equals 30. Now again, remember, the first step is to isolate the absolute value. So we subtract the 3. The absolute value is still there. Oops, that's a positive 27. Now we are back at the last problem where it's isolated and we can create two separate equations, one with a positive 27 and the other one with a negative 27. So you divide the 3 and you have w equals 9 for the first one, divide the 3 and you've got w equals negative 9. And those are my two solutions. Okay, now let's make it a little bit hard. Still having two solutions. We've got 2u minus 2 in absolute values plus 13 is equal to 23. So I subtract the 13 because remember the first step is to isolate that absolute value. So now that's done and I can split it into two equations. 2u minus 2 equals 10. That's an equal sign there. Let's see if I can actually make that a little bit nicer. Okay, then the other one is 2u minus 2 is equal to negative 10. Now you just solve these equations separately. 2u equals 12, divide by 2, and you have u equals 6 for the first one. Add the 2, 2u equals negative 8, divide the 2, u equals negative 4, and I've got my two solutions right there at the bottom of the page. Okay, so those were examples of two solutions where they were sort of increasingly hard, but what you could see was the absolute value was always isolated first. So go on to the last absolute value equation problem, and you'll notice something a little bit different happens. So we've got the absolute value of 3x plus 4 plus 10 is equal to 5. Again, first step, isolate the absolute value. So when you subtract 10 from both sides, what happens here? So 3x plus 4 in absolute values is equal to negative 5. Well, when is an absolute value equal to a negative? Well, it can't be, because the absolute value is the distance. Well, distances are never negative. So at this point, we just stop. There's no solution. And the symbol for no solution is a circle with a slash through it. Let me make that a little bit clearer. It's hard to write with this little stylus. Okay, so a circle with a slash through it. Or you can write no solution. Either one of those would be full credit. Okay, so what we've seen is absolute values with 0, 1, or 2 solutions. Now let's do the absolute value inequalities. So these are similar, but you've got now an inequality. So we can graph these answers on a number line and write them in interval notation. The first one is the absolute value of w is greater than or equal to 6. So step 1, isolate the absolute value. That's done in this problem. Step 2, create two separate inequalities. The first one is w is greater than or equal to 6, and the second one is w is less than or equal to negative 6. So notice, we did two things. We switched the inequality direction and we changed the sign. Now, when we decide whether this is an and versus an or problem, you look at the direction of the inequality after you've isolated the absolute value, and that's important. So when you have a greater than or equal to, they're ors, less than or equal to, it's an and. So that's after you've isolated the absolute values. So since this absolute value is isolated, we can see it's a greater than, so this is going to be an or. So let's look at this on the number line. Here's 6, solid dot because it's an inclusive boundary, and greater than goes to the right. Then here's negative 6, included boundary, solid dot, and less than negative 6. So then in an interval notation, we're going to use a bracket because it's an included boundary, union, bracket, off to infinity that way. So the answer is the two things together, because the directions would have said solve, graph, write your answer in interval notation. So there you go. Okay, now let's make this a little bit harder. A little bit harder problem looks like this. Absolute value of u, subtract 16, greater than or equal to negative 7. Now remember, all of these problems, step 1, isolate the absolute value. So plus 16 you get u in absolute values greater than or equal to, oh gosh, what is that, 9? So then we've got, really basically the same problem we just did. We just made it an absolute value that's isolated, and so now we can switch, and in this case we're still with an or. U is greater than or equal to 9, or u is less than or equal to -9, and then -9 solid boundary off to the left, +9 solid boundary off to the right, absolute value, negative infinity up to -9, bracket, union, bracket, 9 to infinity. Sorry, my handwriting's not good in the best of cases, and then on this little iPad it's even worse, but there you go. Okay, now, I know this video is really long, but you can just stop and start it wherever you need to. Let's do a problem. Let's do, this time, we're going to put the absolute value of v minus 5 is less than or equal to 5. Now, this is different than the last problem, because the last problem had subtract 16 outside of the absolute value. Now we're inside. But on all of these problems, the first step is isolate the absolute value. That is done in this case. So now the second step is to split it into two inequalities. On the left-hand path, I just dropped the absolute values. I've got v minus 5 is less than 5. Now this time it's a less than or equal to when the absolute value is isolated, so it's an and, which translates to where is the overlap. Sorry, let me do that again. So it really should be, let me write it nicer. What we care about here when it's an and is the overlap. Okay, now on this other path, we're going to do v minus 5, change the direction of the inequality, and change the sign on the 5. Now just solve these separately. So v is less than or equal to 10, and at the same time, where will v be greater than or equal to 0? Well, let's look. Here, v is greater than or equal to 0 is this direction, and v is less than or equal to 10 is this direction. But what I care about is the overlap between the two. So my answer is right there. So really, to be clear about my answer, I'm going to pick up the eraser and erase everything that I don't want you to see, because it's not up to the reader to decide where the answer is. So now I've clearly shaded just the answer between 0 and 10, inclusive. Inclusive means the boundaries are included, and so those are brackets, and there's your answer. So the directions would have said solve, graph your answer, and write your answer in interval notation. So the two things together is your answer. Okay, now make the problem a little bit harder. Now we've got the absolute value of 11 minus 2x absolute value less than 3. Okay, remember on all of these problems, step 1, isolate the absolute value. Okay, that's done in this case. Now split it into two inequalities. 11 minus 2x is less than 3. Now, I'll wait a second. Is this an and or an or? Okay, it is an and because it's a less than. So again, we're looking for overlap. So 11 minus 2x. Now this time, flip the inequality, change the sign. Okay, now go about solving this just like you normally would. So subtract 11 from both sides is less than 3 minus 11 is 8, negative 8. Divide by negative 2. Remember with inequalities, when you divide or multiply by a negative, you reverse the inequality. You end up with x is greater than 4. Now same thing on this one. Subtract the 11. Negative 2x is greater than 8. Let's see, 11, 12, 13, 14. I can count. Negative 14. Now let's divide the negative 2. Again, x, now flip the inequality, do the division. Okay, now let's look at this on the number line. X is greater than 4. There's my 4. And less than 7. These are not included boundaries. Remember, this is an and, so what I care about is the overlap. And I'm going to pick up my eraser and I'm going to erase the stuff that's not in the overlap because that's not part of the answer. And again, this is about clarity. I'm trying to show you exactly where the answer is. And if it were an or problem, it would have ended up being the whole number line. So I don't want you to think it's the whole number line. I want you to know it's just the overlap. So the overlap here, now we're going to switch to parentheses because this is a not included boundary. So there's my answer. Okay, now let's make the problem a little. This time we've got the absolute value of 2x plus 21 less than or equal to 28. What is step 1? Remember, isolate the absolute value. So I have to subtract the 21. I still have an absolute value. Now, what is that? 8 minus 1 is 7, so 27. Now, this looks just like the last few problems after we've isolated the absolute value. So now we have 2x less than or equal to 27, and because it is a less than, it's an and. 2x greater than or equal to negative 27. Notice two things happened. You flipped the inequality, negative. Okay, divide by 27, and we have x is less than or equal to 27 halves. Don't change that to a decimal. Just leave it as an improper fraction. We're not dividing by a negative, so in this case, it just stays, the inequality stays in the direction that it has. Let's see if I can move this up a little bit. Okay, now let's look at a number line on this. What we have is x is less than 27 halves. It's positive, so less than or equal to, solid boundary. At the same time, it's going to be greater than negative 27 halves, so solid boundary, going that way. And now I kind of got clever with my marker this time. I didn't shoot my number line way off far because I knew I was just going to have to erase it. So there's the and you can see again it is clear to the reader, now in this case you are the reader, that the answer does not extend beyond that shaded area. Bracket negative 27 halves, comma 27 halves bracket, because the boundaries are included in the answer because of the or equal to. Okay, we're almost done. I know I'm talking fast, but you guys have the liberty of pressing pause and backing up. Okay. Absolute value of 3x minus 1, absolute value plus 10, less than 5. Okay, what is step 1? Isolate the absolute value. So I subtract the 10 from both sides. The absolute value is still on this problem. Now, what is the absolute value of 3x minus 1 less than or equal to 5 minus 10 is negative 5? Okay, now think about this. When is an absolute value less than a negative? Never, because an absolute value is distance. You just stop. You just can't continue this problem. There's no times when these would come out true. Now, let's do the next one. So, by the way, let me just say before we do the last problem, this is tricky for students. You have to kind of be always on your toes and asking yourself, is this possible? Is this possible? Because if you sort of proceed through the problems computationally, you would actually get this right, because you would be looking for an overlap because it was an and, because we see that the absolute or the inequality is less than or equal to, and there would be no overlap. So you should be able to come to the same conclusion even if you didn't notice it at this point. If you proceeded and you were honest with yourself and you completely understood the meaning of the inequalities. So when you have a problem that's a less than or equal to after the absolute value is isolated and it comes out with no overlap, then there's simply no solution. There's no numbers such that you could plug them in, it would make a true inequality. So let's proceed to the problem, and the last one we're going to have negative 5 times the absolute value at 2x minus 1, absolute value less than or equal to 10. Okay, now remember, what is step 1 on all of these problems? Isolate the absolute value. So I divide by negative 5. Now the absolute value is still on the left. We divided by a negative, so you reverse the inequality and you have 10 divided by negative 5. What is that? A negative 2. Okay, now don't jump to, oh my gosh, there's an absolute value and a negative. It's no solution. Because remember, on the left-hand side, we're talking about a distance. So when is some distance greater than or equal to a negative? Well, it is always going to be greater than negative 2, because no matter what I plug in, after I take the absolute value, it's going to be 0 or greater. So this one is going to be all real numbers. Now, all real numbers, because it's one dimension, so it's going to look like this. If you graph it, it'll be the whole number line. You could also write it as negative infinity to infinity. So these things are the same answer here. But to be clear, if it says graph, you have to put the graph. And that would just be the picture I have here, completely covering the number line. Okay, so what I tried to show you is the difference in, so first of all, equations versus inequalities. You have 0, 1, or 2 solutions on the equations, and on the inequalities you either have a union of disjoint sets, or you have an overlap and then it's just a single interval, or you have all real numbers, or you have no solution. So there's sort of 4 possibilities. And all of these, again, were one dimension, and it just had a number line. Okay, this, I just want to remind you, one dimension. When you do a similar problem in 2 dimensions, you don't get all real numbers, because all real numbers is a one-dimension answer. Okay, and that's a different video for a different day. Hope this helped.